Hello everyone, welcome to Grade Up. My name is Hemant Parihar. Earlier we seen combinatorics and proposition logic. Now we will be starting set theory. Set theory is very important for gate purpose and it is the major. It around 4 to 5 marks average always come from set theory. So do it properly, okay, and practice more. So let's get started. Set. So what is a set? A set is a well-defined unordered collection of distinct element. So it consists of many good words. So first word is well defined. So it should be well defined unordered collections. What does mean unordered collection? It does not matter in which order you are collecting, okay, and distinct element. So in a set you cannot have the same element, it should be distinct element. Example, set of all student in a class. So here it is well defined. How it is well defined? All student in a class. It is not like that set you are making some set and you are picking some student, then you are picking marbles, then you are picking it should be well defined. How it is well defined? We are picking the students only, okay. In this way it is well defined. And here y is equal to 1 2 3 4, here we are picking integers, so it is like well defined. So you can denote the set like by using this or this, both can be used. What is subset of a set? If every element of set A is also an element of set B, then A is subset of B. That is the definition. For example, A is equal to 1 2 and B is equal to 1 2 3. Then what A is the every element of A is also the element of B. That is why A is the subset of B. Power set of A. So what is the power set? If A is a set, then set of all subset of A. If A is a set, then set of all subset of A is called power set of A. It is denoted by PA. So it is the set, power set is a set of all subset of A. All subset. Example, here A is equal to AB. So what are the subset of A? Phi is the subset of B, because phi is the subset of B. Phi is the subset of every set, okay. A is the subset of A, this set from here to here, it is a subset of this set. Similarly, this B is a subset of capital A and this is the subset of, which is actually same as A. So these are power set consisting of all the subset of A. Now number of subset of a set with n elements. You need to find number of subset if set A consists of n element. How you will find it? So this is the formula to find it. What does NC naught represent in this formula? So first NC naught is representing the number of ways selecting 0 element from this n element. Suppose A is equal to 1 2 3 so on till n. Now the number of ways to selecting 0 element from it, that will be 1. That is 1, and which is represented by phi. Phi is the subset. If you did not select any element, if you select one element, then you can select one, either you can select 2 or any of them among them. So how many such ways are there? N way, which is representing by NC1. NC1 actually is equal to n. And when I asked you the number of ways to select 2 elements from this element, then there will be NC2. It is what? NC2. And similarly so on, the number of ways selecting of n element is NCN. That will be A set only, which is 1. So if you sum all these, it will be 2n. It will be 2n. You can use the binomial theorem to prove how it will be 2n. You should use the expression of 1 plus x की power n, which is equal to में nc naught into में x naught plus nc1 into में x1 plus nc2 into में x2 so like this, and put the x is equal to 1. Then what will you get? 2 की power n, and this equation will be like this, okay. So in this way we get it that the number of element in a power set will be 2 की power n. If A consists n element, the power set will consist 2n elements. Now what is universal set? Set of all object under discussion. So first we will define what we are having universal set. So what is under discussion, we defined it, and that is denoted by U. Now what is set union? So these are the operations on set. These are the operations on set. Set union. So A and B are two set, and we need to do the union of these two set. So how will be union will be represented? This is A, this is whole A, and this is whole B. And how A union will be X, such that X either belong to A or X either belong to B. So X, this will denote the whole blue region is denoting A union B. Okay. Set intersection. So intersection means that that element should be presented in both set A as well as in set B. How it is represented? X, such that X belong to A, okay, and X belong to B. So in this way we represented. See, this is A set, this is B set, and what is the intersection of both? This area. This is shaded area. Symmetric difference. Symmetric difference is important. X, for all X, X belong to A or X belong to B, but X does not belong to A intersection B. Okay, here it should be intersection. Okay, here it should be intersection, and it should not be this X belong to A or X belong to B, but X does not belong to intersection. So how can we represent it using Venn diagram? This representation is called Venn diagram. Try to draw for it. Okay, try to draw it. I am drawing it here. So this is A, this is B, and symmetric difference will be this area and this area, A and B. This is what the, but should not be intersection. Complement of a set. If A is any set, then complement of A denoted by A complement is A complement X. X does not belong to A and X belong to universal set. So this is the diagram for A complement. So see, this is A, and what is A complement? This area. Okay, this area is whole A complement. Set difference. If A and B are two set, then A minus B is X belong to A and X does not belong to B. So it is A, and you have to minus A minus B. So you just remove the area which is inside the B. So this is A minus B. These are very basic things, but still see them once and quickly, and then go to the higher things. Okay. Cartesian product. So what is Cartesian product? Ordered pair. First we will understand what is ordered pair. Pair of element in specific order. Here element are in specific order. For example, A comma B. So A is coming first and B is coming in second. But it should not be equal to, you cannot, it is not equal to B comma A. B comma A is different, where B comes first and then A comes second. It is different, and this is different. That is what is meant by ordered pair. Elements are in some order. Cartesian product. Let A and B be two sets. A cross B is equal to A comma B. A belong to A and B belong to B. Okay. So here A, this A is belong to A, and this B belong to capital B. This will be the A cross B. A cross B will be different from B cross A. Always remember, in B cross A what will be happen? B cross A, it will be B comma A, B belongs to B and A belong to A. So here B comes first, which is from the set B, that is B comma A. So A cross B and B cross B will be different. We will see the example to understand it better. 1 comma 2 and B is 3 4 5. So when you take the Cartesian product, you pick this element, fixed it 1, then with 3 4 and 5, so these 3 elements are there, and with 2 similarly you can get 3 more elements. So can you say how many number of elements are there in the Cartesian product? If A consists n element and B consists m element, how many elements are there in A cross B? This sign represents the cardinality of the set. Cardinality, what is cardinality? The number of element in that set. So if the cardinality of set A is n and cardinality of set B is m, then A cross B cardinality will be n cross m. For each element in A, we will be having m option. And how many such things are there in A? n, that is why n cross m. And what will be the cardinality of the power set of A cross B? The cardinality of the A cross B will be 2 की power n into m. I proved this formula in the previous slide. Okay. Now what is relation? Relation from set A to B is defined as R is a subset of A cross B. So any subset of A cross B will be a relation between from set A to B. Any subset of A cross B will be a relation from A to B. Means R is a subset of A cross B, and relation is also a set. That is important. Okay, relation is also a set. Example, A is equal to 1, 2, 3 and B is equal to A, B, C. Then you will take the Cartesian product and I take the subset of it. A, B, 2, C, 1, A and 3A, and this is the subset of A and this is the relation. 1, 2 and all these belong to R. So we write like this. It means that 1 is related to B. What is mean that 1 is related to B, 2 is related to C because we will be having here, and 1 is related to A. So this is just the way we say it. And if there is not element belong to R, then we write A does not relate to B. Now we will be seeing there are many type of relation, and now we will be seeing reflexive relation. A relation R on a set A is said to be reflexive if for all x belong to A, x comma x belong to R. Try to represent this equation. For all x, this means for all x that belong to A, x comma x belong to R. If you miss one element from A such that x comma s does not belong to R, then this is not gonna be true. Then the relation will not be reflexive. It is clearly saying for all x belong to A. In prepositional logic, I told you that how to make the for all things negation of for all. How to, if one element does not satisfy that property, then for all x become false. That is what is means here. Okay. So understanding the propositional logic very well is very important. It really helps to understand the statement better. Example, A is equal to ABC, then R1. Tell me, is this relation is reflexive? A comma A, B comma B, C comma B. Yes, for all of the element of this set A is present in this relation R1. That is why it is reflexive. And you will also say, sir, here we do not have any B element. Actually, we are defining this relation on A cross A. Okay, this is the subset of A cross A. See R2. Tell me R2 is reflexive or not. A comma A is there. Okay, I don't need to see this also. B comma B is there, and again A comma A is there. This should not be there. Actually, it is by mistake it is written. So we will be having A comma A, B comma B, but we will not be having C comma C. So this relation is not reflexive. This relation is not reflexive. Now we need to find number of reflexive relation. Here it is the formula. How you will find the number of reflexive relation? How you will find it? We will try to find it. So let's A is equal to 1, 2, 3, so on till n. Now what will be A cross A? A cross A is equal to 1, 1, 2, 2, 3, 3, so until n, n. Then we will be having 1, 2, then 2, 1, and all those are the elements. Okay, how many elements are there in A cross A? The number of element in A cross A will be n square. The number of element in A cross A will be n square. And how many these elements are there? Because it is our condition for our relation to be reflexive, these elements should be present in it. How many numbers are there? Such there n numbers are there. Okay. For all of these numbers, what the choices we have to make the relation reflexive? All of these should be present. So for all of these numbers, we have one choice. And now see this number. If these numbers are present in my set, then if I am taking this or not taking this, does not alter that it will not be reflexive or it will be reflexive, because our relation already become reflexive if we include all these numbers. So this number can be present there or cannot be present there. So how many possibilities are there for this number? 2 possibility. Similarly for this number, how many possibilities are there? 2 possibility. And if I like 1 comma 3, so how many possibilities are there for this number? It may present or may not be present. It does not affect anything. So 2 and I have to need to multiply. So 2 into and so on. For every element, other element, then this n element, we need to do that. How many such elements are there? Actually you subtracted from n square minus n. How many such number are there? N square minus n. These many numbers are there, and for these we will be having 2 possibility. That is why it will be 2 की power n square minus n. This is what it is written here. So you understand how many number of reflexive relation are there. Understand this because it is important. Number of reflexive relation. Irreflexive relation. Irreflexive relation, a relation R on a set A is said to be irreflexive if for all x belong to A, x comma x not belong to R. It is also telling that for all x that is belong to A, for all x comma x does not belong to R. So earlier in reflexive we are saying that x comma x belong to R for all x, and it is saying that for all x comma x does not belong to R. So if we found any element of A that is belong such that x comma x belong to R, then we can say that it is not reflexive. I will tell you. For example, A is equal to ABC. This relation is there. Does we be having an element like that A comma A belong to this set? A comma A, no. B comma B, no. And C comma C. So I can say that it is not reflexible. It is not reflexible. Is it reflexible? No. This relation is also not reflexive because these 3 are not present. Our relation cannot be both. Our relation cannot be both reflexive as well as irreflexive, because one is saying that for all x comma x belong to R, and other is saying that for all x comma x does not belong to R. So no. See this relation B comma C and C comma A. Is this relation is reflexive? Yes, because these 3 are not present. It is irreflexive. It is also irreflexive. But see another example. R3 is equal to A comma A. What is this? Tell me. It is reflexive? No, because we will not be having other 2 also. So it is not reflexive. It is irreflexive? No, because we will be having one element A comma A. So it is not irreflexive. So actually how the set you can, if we consider the set of all relation, then number of reflexive relation are there and number of irreflexive relation are there, and there are some which are not any, like that. It is not reflexive as well as it is not irreflexive. So they are disjoint set. Reflexive and reflexive will be disjoint set. This is the one problem on GATE CSE 2018. The cardinality of the power set of this. We need to find the cardinality of the power set. This first we need to take the power set of this set, and then we need to find the cardinality of this, means the number of element in it. So first, if a set A contains n element, then power set of A will consist of 2n element. Okay, then I can directly say that my answer should be 2n. See here how many elements are there. Some students do mistake in if they try to answer a question very fast, they do some mistake. They will say there are 10 elements. But no, there are 11 elements. We are starting from 0. That is important. So the answer will be 2 की power 11, and that is 2048. Okay, don't take it 10 element, otherwise you will lost very important, very easy question, and you will don't feel good about it. Okay, so these are the basic about relation and set. We will be seeing other concept in an upcoming video. Till then, keep practicing. Okay, thank you.